The Earth, and all life on it, is vulnerable to many events that could cause its extinction. Some are well-known threats, and some are unknown. Out of the ones we know of, asteroid impacts are a well-known scenario. The history of the Earth has shown that they are a real and important threat, which is why we make sure to keep an eye out for objects in the sky. NASA and Space Force are collaborating to increase planetary defense by finding, tracking, and categorizing near-Earth objects. NEOs are asteroids, comets, and large meteors that have an intersecting orbit with Earth. Knowing about these objects and their trajectory can give humanity a warning if a collision should happen. Currently, the only method to detect them is through taking pictures of the sky and watching for movement. This means that we need the sun to illuminate them properly to even see them. All those out of the sun's grasp are impossible to detect, although some are easier to detect than others. There are two types of rocks that can cause serious damage on Earth. There's comets, which are made of ice and dust. Once they come closer to the sun, they heat up and leave a trail of gas, which makes them easier to detect. Asteroids, on the other hand, are made of metallic or rocky materials and reflect very little light, so they are harder to detect and are far more common. Throughout the Earth's history, there have been many impacts that we know of. Some are barely noticeable, some leave a trace, and some have a global effect on the Earth's atmosphere, topography, and cause mass extinctions. For example, the asteroid that wiped out the dinosaurs is considered a big impact. It impacted in today's Mexico, creating a crater 20 kilometers deep and 180 kilometers in diameter, but its effects were felt on a planetary scale. This asteroid is estimated to have been around 10 kilometers in diameter and hit the Earth at a speed of 43,000 kilometers an hour, which is almost 35 times the speed of sound. Once it hit the Earth, it generated a lot of heat and energy, which directly and indirectly killed 75% of all life on Earth. The energy from a giant impact can cause volcanic eruptions to occur around the globe. It also leaves a lot of debris in the atmosphere. Some of it fell back down to create more smaller impacts, but the layer of ash created in the atmosphere stays there and blocks the sun. This is what creates an impact winter, and it's responsible for the mass extinction of plants in that period. These type of world-ending impacts are extremely rare, and there isn't much we can do about them. A more plausible scenario is the Behringer crater in Arizona, measuring 1.3 kilometers in diameter and 170 meters in depth. Around 50,000 years ago, an asteroid about 40 meters in diameter, made of nickel and iron, came crashing down to Earth at a speed around 20 kilometers per second. Once it impacted, the resulting kinetic energy was around 2.5 megatons of TNT, or 150 times the energy released in the atomic bombs on Hiroshima or Nagasaki. This is considered a small impact since the asteroid was quite small and it didn't have any planetary consequences. Ever since we've been looking for asteroids, we can also see some close encounters. In 1983, this comet came as close as 4.6 million kilometers from Earth, the closest one in over 200 years. To put this in perspective, the Moon is around 384,400 kilometers away. This makes the comet 12 times further than the Moon is, so relatively not that close. But on the cosmic scale, it is quite close. Thankfully, this comet didn't collide with Earth, because with a diameter of 9.2 kilometers, it's nearly the same size as the asteroid that wiped out the dinosaurs. But what if we can detect an incoming asteroid? What can humanity do to stop it? There seems to be two working methods that depends on factors such as the size of the object, the speed, the mass, the composition, and the amount of time we have before impact. Nukes are one of the main theoretical methods of destroying an asteroid. It would be far more effective to use on bigger asteroids and comets. Nuking a big asteroid could simply make it into many smaller asteroids, but this is actually good. The Earth's atmosphere already protects us by burning up these objects. Every year, asteroids the size of cars enters the atmosphere, but completely burns up before even touching the ground. The big asteroid being destroyed into smaller asteroids creates a bigger total surface area to burn up. It could make most of these completely burn up in the atmosphere, and the rest of them would become so small once they hit the ground they would barely make any damage. If you ask me, that's a better alternative than city-wide catastrophes. Of course, with all that being said, this method should be used as a last resort since deflecting an asteroid is far safer and the results are far more reliable. But deflection is not easy by any means. One method for deflecting an asteroid is to use a rocket. This method is quite unfeasible because the current rocket technology can barely lift over 100 tons to orbit. Forget about moving an asteroid like the one that wiped out the dinosaurs, weighing a minimum of 1 trillion tons. The best current method for deflecting an asteroid is to use reflective paint or reflective panels. These would be the same concept as a solar sail, but instead of using the sun to accelerate a spacecraft, it would accelerate an asteroid out of the orbit of impact. The bigger the asteroid, the more reflective material would be needed, but also more time. Not to mention, we would have to detect the asteroid in time and land a spacecraft on it, although NASA did manage to land on an asteroid back in 2001. Of course, a cool futuristic method would be asteroid mining. Some of these asteroids have a lot of gold in them, which can make it a pretty profitable venture. Never mind the economic collapse of the gold market that would ensue by saturating the market and turning gold from a precious metal to a worthless one. Another currently unfeasible method would be to just leave Earth. Evacuating all 7.7 billion people to another planet in the span of a few weeks seems less feasible than deflecting, destroying, or mining these asteroids. In the worst case scenario, what if we can't stop an asteroid like the one that wiped out the dinosaurs, and it does impact Earth? Is there something we can do to ensure our survival? Once the asteroid is detected and we know its size and impact location, the first action is to evacuate the impacted area. Since Earth's surface is mostly water, the asteroid would have a 70% chance to hit the water. Now, that's not a good thing. The massive tsunamis would add to the problem. Being away from the shores and being above water level would keep you safe, but most of humanity is located on the shores, barely above water level. So, as long as you're far enough away from the impact zone, being underground is actually your best solution. The implication is that you can have your own air supply or filter the air from the atmosphere. A giant asteroid impact would cause several volcanic eruptions and fill the air with toxic chemicals along with pulverized rock material. This would make breathing the air dangerous for all forms of life. Therefore, you would also need a fresh water and food supply. The Global Seed Vault is a bunker in Svalbard where seeds from all the plants from all the countries in the world are stored. The asteroid would cleanse the planet of most of its vegetation, and seeds would become a very valuable commodity. The energy source would also be a crucial aspect of survival. After the impact, the Earth would have a high surface temperature, but because of the atmospheric changes, sunlight wouldn't go through the atmosphere, and as a result, there would be global cooling. The energy source could be anything else other than solar-based. Most of the energy generated would have to be used for heating and food production. One reliable energy source in such a scenario would be the Earth's core. My guess is geothermal would be the main way of producing energy. Now, all you need is a space to ensure humanity's survival. Fortunately, many people are prepared for an apocalypse. There are bunkers and missile silos that have been built into the ground for this sole purpose, and there's an area with a collection of bunkers above ground. But bunkers are not the only infrastructure that can be used in this scenario. Underground cities are a series of infrastructures connected by tunnels and subway systems. These infrastructures would have a lot of useful supplies in an apocalyptic situation. The Burlington Bunker is an example of an underground city. Built in the late 1950s for the Cold War, it's a 35-acre network of secret entrances built to house 4,000 people in case of a nuclear strike. It was built to be impervious to bombs, radiation, and a toxic atmosphere. Like our ancestors, the best way we could survive an asteroid strike is by going underground. With enough time, we could devise plans and create technology to protect ourselves against cosmic impacts, or just completely leave Earth. Fortunately, space is so vast that Earth seems and is incredibly small on the scale of the solar system. And thanks to Jupiter and its immense gravitational pull, it is our biggest protector against the apocalypse.